think it's just coming to 5 and we should start on time. Thank you all very much for being here, and I'm also happy there are so many younger people in the audience, and I hope that this will be really helpful for things that you might want to do in the future. I'm really grateful that the guest editors, Alok and Sudha and Rakesh, made this proposal about a special issue on the rare genetic disease research landscape in India. And I'm Renee Borges, the editor-in-chief of the Journal of Biosciences. And I think the moment I got that email, I responded immediately saying that I thought it was a really wonderful idea. Yes? And as you will see from the compiled articles that we will release during this function, I'm sure you will realize what an important task and how much heart and grit has gone into this issue. Just to make some comments, I mean, on a lighter vein, I was a few weeks in France and just got back. And while in France, I read that King Louis XIII was born with a double set of teeth. This is a genetic condition called hypodontia. Now, of course, if you have a double set of teeth, I suppose in that time, in the 16th century, might have been without anesthesia, difficult to extract the extra teeth, but it gave him a stammer and a stutter and a speech impediment, but nothing more than that. Yes? But you will see that all the diseases that we are talking about are certainly far more serious than having a double set of teeth. Yeah? And I think that for us, we think of statistics. So what is a rare disease? How do we define it? Which we can talk about during maybe the panel discussion. But we shouldn't forget that every statistic is a person. You know, is a person who is loved, wants to lead a normal life, and it should not remain just as a statistic. So I think that the effort of this rare genetic disease research landscape project is really to waken up people, scientists, and the community at large to how important it is for all of us to be empathic and to realize that that one statistic is as important as if it were a million. Yes? So I think I don't have really very much more to say. I wish that the Academy will take this first step and take it forward. I know Alok, Sudha and Rakesh have plans to take this effort forward, and I wish them all the success and, you know, all the help as long as the Academy can help in that. So with that, I'll invite Alok to tell us about this. Thank you.
Well, I must say that it was a great experience in working on this volume. And I must give you a background when we actually thought about it and how this whole idea came along. You know, the rare diseases seems to be, as the name, a lot of people said that don't call it a rare genetic disease. Somebody said orphan disease. Some people say neglected disease, but generally this term is around for some time. And if you start looking at it, you'll find that almost everybody I talked to, everybody knew that there is someone they know of who has a disease which falls under this rare genetic disorder. Everybody seems to know someone, some family, neighborhood, etc. So it turns out that it's not that uncommon. And second thing is that some of the people not very aware of what this disease is. What is it? I mean, what is the problem? It could be some other problem. And surprisingly, if you go to clinicians, and clinicians were also not aware of many of these diseases. In fact, if you name some of these diseases, we went to a neuroscience clinician, neurologist, and asked few of these diseases, and this person said, I never heard of it. So it slowly dawned on us that the awareness about these diseases, even among experts who are supposed to know, is not there. Second thing, we noticed that a lot of scientists, and I don't mean to say anything, they're interested in working on cancer, solve cancer problem. So I asked many of them, various interview and other places, said, can't you think of some other problem which are doing? Have you heard of genetic disorders? Have you heard about rare genetic disorders? People haven't heard of them. So they all want to solve, and I would tell you, 70% roughly 70% of people who do PhD postdoc in biology wants to solve cancer problem. Okay? So, I mean that, and they are not even aware of problem that exists elsewhere, problems of like rare genetic disorder. When you try to explain to them that they also constitute fantastic option to do great biology. After all, they are mutations and you can actually study how the mutations affect phenotype, etc. So that's also not there. So, and we tried to make a consortium of people, scientists, clinicians, etc., who will actually work on it, basically developing consortiums which will work on some of these diseases. Then we realized that though people are not working on it, people may not be that familiar with it, but when you explain to them, then it turned out that everybody is interested. And I don't think anyone said no to me, and eventually we built a consortium of 52 scientists from 23 institutions. And some of the people here are actually members of that consortium. So this all led to the idea that, and in meanwhile what happened was that Tata Institute of Genetics and Society, along with ORDI, a patient group, organized a meeting called Redress, where large number of people working on rare diseases were there. And it came to us that, look, people are there, they may be scattered, and the work may not be very coherently, published or coherently presented. So why not bring all this thing together in one place, and at least try to have a journal, special issue of a journal, which documents all the research that is being done in the country. And when this idea was coming, and I wrote to my good friend Rene, said that this is some idea that we have. We want to bring all these people together, come out with a volume that will document the work that is going on in the country. There are problems that are there in the country and people who are there. And within an hour or half an hour, I got a response. Great idea, go ahead. I mean, this is the fastest approval process that we had, and slowly she said, send me a proposal that I can take to my editorial board, which we did. And I think in 2-3 weeks, you had an editorial board meeting coming up. In 2-3 weeks, we got a letter saying, please go ahead, give us details. That was about a year and 2 months back or something. And then there was this long process where all this issue came out. Just about the issue is that you will see that there are quite a few review articles actually, and essentially, kind of summarizes work in that area. This also essentially shows that work in India on rare genetic disorders have started, papers have started coming, but people are documenting what the knowledge is there in that area with respect to the patients that are seen in this country. So this volume is going to be a great kind of reference volume for anyone who wants to pick up knowledge about rare genetic disorders. And the volume deals with all issues from sociological aspects to regulatory aspects to policy aspects, everything from basic biology to drug discovery, methods, etc. All these things are there, articles from all this area. So essentially, kind of summarizes what we know and what we are aware of as of today, what direction to go, etc. Now, that's about it and how it started. Obviously, we want to take it forward. We want to take it forward to a level where we can see fruits of all the research that is happening. Now, I just want to add one point here, and my friend Dr. Gupta would probably take it further to do that. I think this time has come for us to not only do great science, publish papers, but go beyond that. It's important for us to go beyond that. Now, and being a practicing biologist who has only done this basic research and published paper all my life, I find when I'm looking at it, I find the path from lab to patient is a long one. And somehow this country is not geared up to it. In fact, I don't think you will get great advice from DBT, DST or ICMR about how to take it forward. They are also grappling with the ideas. They're also learning how to do that. So we would like to take that. And there are people here who are all eager to, I think there is a consensus in the country which is saying that, look, let's go beyond this. Let's go beyond just doing basic research and see how we can take it forward as a drug level. And some initiative has been made, and we plan to take these ideas much more further to see how to do that. The path seems simple, but it's not that simple. And for rare genetic disorders, the path is much more complicated. In fact, we had an online meeting on 13. We were discussing this issue, how to do clinical trials, how to, etc., etc. So these things will follow as we go, as a future initiative to do that. Now there are organizations, Tata Institute of Genetic Society, etc., who are very much into rare genetic disorders. So that's what I feel is going to be important to go forward, summarizing the knowledge that we have, learning more about diseases that are prevalent in India, learning more about the kind of mutation that are there, the phenotype that we see in India, how it is the genetics of those, all this, along with all the regulatory aspects of it, and how to get eventually treatment for these diseases. in this whole effort of coming out with the journal, there were many people who played a very key role in this process. First and foremost, Professor Rene Borges has been a great help. I mean, every step, every article she went through herself. Even when she's sitting in France, she was editing some of the articles that came out. Okay? So I like to thank her profusely for making this dream come true, this article coming out. Then I have my co-editors, Rakesh and Sudha. They worked very, very hard. In fact, we had to sometimes say that, please, some journals, the articles are sitting with you, please, you have to do something about it. And they actually went about doing this. I like to thank all the authors who have contributed to it. Many of them are sitting here. And without their help, of course, the journal will not come out. And the people who have reviewed the articles. Reviewers are always, we don't think reviewers are important, but reviewers are most important for a good publication because they are the ones that play a very important role. I would like to also thank Professor Vinod Paul for writing foreword for this. He, when I wrote to him, he immediately agreed, and in spite of the fact there was not enough time, he sent his article on time for this. Then many people from academy helped us a lot, and I want to thank them, Sushila, Vinuta, and of course Mahesh Chandra is there everywhere. He helped in organizing this meeting. And then Professor Gupta, who readily agreed to come to today's function, and he will be giving the keynote lecture today. Prashant, and also agreed to come and give a lecture. Thank you very much. They're all busy people. And then, of course, the panelists here, Madan, Gayatri, Raghu, and of course, Sudha and Rakesh. And thank you all for accepting the invitation and be here and make this program a success. So thank you all for attending this function. And I would like you to look at the issue and tell us what you think can be done if you want to come out with the second issue, or how do we go forward from here. Thank you. Professor Y.K. Gupta for giving that keynote lecture here. And a lot of people who are not, who do not know Professor Gupta, he was a professor of pharmacology and actually built the Department of Pharmacology at All India Institute of Medical Science in New Delhi, an eminent person about drugs. You want to know anything about drugs, how to develop drugs, what it does, etc., Professor Gupta is the person to do that. But though we have an interaction, we did some work together, but I see him as a champion of rare diseases and rare disease drug discovery. His knowledge about drug development, regulatory affairs, etc., is amazing. Right. So obviously we are using him for this, helping us out in this whole process. He's currently chairman of the Board of Governors of AIMS Jammu, and Professor Gupta.
You want to say that?
use.
Thank you. It should. Great. Thank you very much. And before I say something, my regards to and thanks to Professor Alok Bhattacharya, who did not request me, but whenever he says, it becomes an order for me. And particularly anything which is for rare disease, even if I am busy somewhere or I am not well, that's what I said yesterday, I will be happy to talk on VC, but then I decided that I must go. And my great appreciation to my friend Dr. Rakesh, and of course Dr. Sudha and Dr. Rene, who are the editors of this special issue. And what I feel that writing such a special issue requires a specific bonding for the cause. Unless you have that, so this is a real mix of science and the mind. Your heart has to be there before you initiate such thing, and particularly working on rare disease. So my salute to all those who are author to this, including those who have been mentioned and those who have not been mentioned, because the rare disease or orphan drug article scientists are also behave like an orphan on this issue, because they are, and entering into this area requires a bit courage, requires a bit of dedication, and requires a lot of out of box thinking. So you all are tremendous and very high level expert in molecular biology and genetics and all those things. I will not go into that detail, but what we thought of, what has been the problem in bringing the rare disease drugs in the country fast, in the globe and in the country fast, and then what should be the strategy, what are the roadblocks. If you understand what are the roadblocks, then we can create a strategy gradually and educate those who are in the policy making process. See, creating science, as very rightly said, we need to go beyond publishing and patenting. Bringing that for the benefit of the patient is ultimate goal. And for that, if the roads are not labeled, not clear, then it is our duty to bring it. The regulator often says that we do whatever we see, whatever we read, and they don't want to drift anything, a line. And then it becomes our responsibility to create evidence, to create something new thing, so that it becomes easy for them to apply that. So with that background, I will just give you some idea that what are the challenges and what could be the strategies in rare disease drug development. And this is, all of us know, just for recap, the definition of rare disease is still a challenge. What should be the definition of the rare disease? Because if you just see, there is no uniform definition which is universally acceptable. And still we are in ICMR, Government of India is still struggling. In Indian context, what should be? So I have just collected this. WHO says that prevalence of one patient in less than one in 1,000 population. That is the US WHO says. Whereas the US FDA says that less than 2 lakh patient in entire US population. They have a very good registry system, much better registry system than anywhere. In India, CDSU, when we developed, I chaired that committee, New Drug Clinical Trial Regulation, and it was arbitrary, not arbitrarily, it was decided that one less than 1 in 5 lakhs population. That is the rare disease. And that came with the calculation at that time that 1 in less than 1 in 2,500 population. You convert at that time the population, it came about 5 lakhs. So now you may think, what could be the reason why you have this numbers when you say rare disease in a country? So the connotation is that we have the idea of the number of the patients suffering in that population, which will direct a lot of policies in that, and not a disease burden. So that was perhaps, but so this is again in ICMR, and so this is again a matter of consultation process, evidence, discussion, that what should be the disease burden, where we should call this as a rare disease. Because it is also important, the government of India says that if you have a rare disease, the new Supreme Court direction, the policy, then you have got a lot of grants and the subsidy and the price control and all those things. Now, therefore, inclusion a disease into the rare disease becomes a challenging task. And that's why the important thing is how to define it, and that's why the debate is. Mostly it is 80% or more than 80% of rare disease are in children. But recently there have been concern that about 20% of the rare disease are also in adults. And they are diagnosed much later, but the mortality is also there. And that is also one dimension which we'll have to think about. The other important point is the average time of diagnosis is 4 to 5 years in developed countries. In India, we do not know that because there is no vertical or horizontal study that what is the time of diagnosis. And the important thing is how many people are diagnosed, and this may be the tip of iceberg or it may be different. And how many children are not diagnosed because there is no referral system. First of all, if it is in the village, it has to be identified that this is not treating. The physician has to have a right referral system. From there, it has to go to the tertiary care, and there has to be a diagnostic procedure, and then they will be diagnosed. So it is also important that where is diagnosed versus undiagnosed is an important critical issue as far as India is concerned. I am raising these points because these are points which can be maybe of research question, epidemiological research, or whatever it is. Now, specifically challenges in India, they are just, maybe you can add many more to this, or maybe you can say that some of these are not challenges, but I feel definition to begin with, the prevalence in epidemiological data is a major issue even today. Where is the registry has been started by, a couple of registries have been started by ICMR, but who is feeding into that registry and how many are not fed into that registry, and whether in the registry where the accurately diagnosed cases are there, and what is the diagnosis criteria you are using. This is again whether this registry is the correct reflection of this disease or this registry is just an indicative or just a guess. So that becomes the important thing in the registry. When a person is not aware, when the physician are not aware, what to talk of patients, when the doctors are not aware that this is the rare disease and then is a time to refer it, not to continue treating it, then the registry, what the registry will do? Ultimately, registry will only happen when there is awareness. And this awareness cannot happen unless there is a mass awareness campaign right from the MBBS level that this is also one has to look for. And what we do, this becomes only DM question, not even MD question. So this is something. The expertise is again a challenge. How many experts are there who can identify and then who can diagnose correctly, and then next is who can appropriate guide the treatment strategy for that. They will say that there is no drug is available. Then there are some drugs, some strategies which are available. So this is again, and therefore with this reflection, the central government has created 11 Center of Excellence. in different, there are 11 center of excellence, but these 11 center of excellence also be trained. They have to show their excellence and by some parameters. So that is also expertise. Early diagnosis is an important thing. Because if you diagnose it as early as possible, perhaps the treatment or the strategy can be decided much faster. The costing can be decided, the insurance can be decided, and that is what, but the diagnostic tools are so insufficient, so expensive, that this also becomes the priority of Department of Biotechnology Research. Ability to treatment is a very important thing. Ability to management and ability to treatment. Treatment means specific treatment. If there is an enzyme replacement, then it is a very important that you have to have a necessary funding support system. You have to have the accessibility of the medicine. Not that every time you have to depending on foreign substitution or maybe court, Supreme Court direction or High Court direction, then you do it and the government tries to do it. If there is a direction to a medical college that you have to treat this free of cost and the college says that my total budget of a year is less than the total budget of the cost, how can I do that? Court gives the direction, but the implementation becomes an issue. Even for as far as the All India Institute of Medical Sciences, where the court gives the first direction, and I do not know how they complied it, I did not go into that detail, and that's why the affordability. Even in India, the Ayushman Bharat or any government funding mechanism will not be able to so effectively afford the treatment for all the rare disease patients. And therefore, it has to have, and the insurance companies, they do not comply with. I do not know how it will happen, but then what can be the affordability is the making cheaper drugs, available drugs, and some alternative treatment. And that's why the important thing of the research is important here. Challenges, I will just focus on in drug development for rare disease. Why pharmaceutical industry is not so keen? Because natural thing, pharmaceutical industry wants to make money also. Make money also, not. Primarily they want to make money, if I say, put it that way. And this, as compared to anti-diabetic and even anti-cancer drug, this is a much more complex to bring a drug for rare disease, even much complex than anti-cancer drugs. Much less is anti-diabetic drug and much simpler is make all other drugs for analgesics and things like that. And they are much assured business, much assured return on investment, and another challenge is less number of patients, small number of patients, and not only the small number of patients, you have unpredictable use. You have, suppose you know that there are the 5,000 patients of this disease, but how many patients will afford treatment to take this? That is unpredictable. Whether they will get money to buy this or they will switch over to this drug, so that is unpredictable. That brings the deterrent for industry to take effort in that. And then is apprehension for price regulation. In country like India, we cannot afford to lose the price regulation. But also, the industry looks that if there is a price regulation and my return of investment doesn't come, then it is better to develop a drug in US and UK. So I am part of this process, but I know the limitation that this also becomes. And so NPPA of price regulation versus affordability and versus return on investment. So these are the three triangle which is very difficult to meet. The industry wants that return on investment, how much return on investment in terms of money, in terms of time, in terms of human resource, and then what is the investment return they are getting it, as compared to the anti-diabetic or any other proposition. And that's why this becomes a deterrent. Why rare disease is not a priority for academic researchers? That's why I salute you all those who are working on this. Because, maybe I may be wrong, lack of animal model, because many of the basic scientists like me don't find the rat and how to do this model and therefore how to publish quick paper. And that is where how to develop in vitro. But these are the attempts which are going on. Maybe how much predictability is, that is a second issue. High cost of research and limited funding. Now, after the direction of court and the ministry, there has been huge enhancement on funding on the rare disease, but there are no takers yet. There are no takers yet. Funding has been increased to multi-fold, but for the funding takers on rare disease are not many. I know because I have been sitting in this. The time consuming and slow publication. People are interested in academic institution that at least 5 publications should be there before their application is considered for promotion to professor. And if you are working on a rare disease, maybe there will be 1 or 2, and much rejection, much alteration, much revision, and therefore this also becomes a less attractive proposition. And what is required for that, I think many of us, Dr. Rakesh and Dr. Alok and sitting here, need to encourage with collective effort. That is Department of Science and Technology, Department of Biotechnology, ICMR. There are 22 All India Institute of Medical Sciences. Motivate them. There are several NIPERs. There are 6 NIPERs who have, one of the NIPER has been entrusted on that. And there are several CSIR institutions, maybe CDRI, maybe IITR. And these are, and etc. That means there are a couple of other institutions who have a very high grade of scientists. Motivate them, fund them liberally, and then evaluate their projects with open mind. And maybe we can have a consortium of all those who can just do that and evaluate these projects in differential manner. The challenge here is that it is very difficult to know the natural history of the rare disease. We know that this is the COVID natural history. We know that this is a typhoid. We know the natural history of tuberculosis or diabetes or anything. And therefore, once you know the natural history, you know the rate of progression, you know the type of progression, then you know how to interpret the results of the intervention. But when you do not know the natural history, then therefore a study has to be done that what is the natural history. And when the natural history you can only find when you detect the case as early as possible. And then you see, follow vertically and then till death or till the patient recovers. So that is one important thing, need to study is necessary for protocol development and the study effect intervention. And this is one of the area which can be done by even non-medical person, a semi-scientific person. Rate and pattern of progression, variability among patients is too high as compared to any other thing. Heterogeneity. Lack of established endpoint. We do not know whether the patient says that I am better, that should be endpoint, or when you say the FEV1 or maybe the respiratory endpoint, or you say the muscle strength increases, that should be the endpoint, or you have a specific biomarker, what should be the endpoint, or there should be complex of this. And therefore, when you see different papers, different people have used different endpoints, and that becomes more complex here. Validated biomarkers. Now, many people have done that. This could be the biomarker of muscle myopathy, this could be biomarker of respiratory, this could be the surrogate biomarker because there is no biomarker. So that is one important thing, validated biomarker. Phenotypic heterogeneity. The important thing is when you do a clinical trial, you have to give a patient or subject, in this case patient of course, a standard of care. And otherwise this will be unethical. So what should be the standard of care? Even the standard of care has not been able to, even this 11 Center of Excellence has not been able to make one standard of care for one particular disease. Because there is a heterogeneity, there is a variability. And therefore, if you are giving an intervention to one patient, the other patient has to have, or person has to have a standard of care. So you can compare. You can, if you deny the standard of care, this will be unethical. So that is again an important challenge. Anticipated safety issues based on the animal data. There is very few animal data because the prediction on animal to human is much lesser as compared to prediction of animal to human in case of diabetes, hypertension, analgesic, antihypertensive or anti-cancer drugs. Here the prediction, because that enzyme may not be present in animal. This can be only surrogate. and therefore prediction from animal data to human, and therefore assessment of toxicity in human when the drug is given is become more important. That is important thing. Immunogenicity testing in therapeutic proteins, particularly genes and cellular products, because you cannot have as high level of predictability as in animals in case of this. And therefore, what is important here, particularly for this group, and that's what the DCI says, that, and I say that you have to do out-of-box thinking. You cannot do conventional process, and you have to assess the scientific judgment. And I always say, in this case, best fit line. You will not say the ideal line is that's the best. You have to see whether what is the risk, what is the benefit, and in this situation, as compared to other drugs, where you assess that the risk and benefit, even this risk is higher, and there is an anticipated benefit in the, because the patient is dying or disabilitating, then higher acceptability of the higher risk is acceptable, should be acceptable, provided you do a scientific validation, scientific process in that. That's why out-of-box thinking. There is a major issue in patient selection. You have a patient, group of patients. Now, you have to have availability of the patient for clinical trial. Just giving the number that we have 1,000 patients of this disease, it doesn't make sense. How many patients for introducing a new drug? How many of these patients will be able to be enrolled after inclusion, exclusion criteria, after giving ethics consent? Very few, because there's lots of issues in that. And therefore, if you have as stringent criteria as you do in conventional RCT, inclusion, exclusion criteria, you may find maybe 2% which could be included in. Therefore, you have to have a slightly different mind setup for inclusion, exclusion criteria in this. And for this, not only ethics committee members have to be trained, the regulator has also to be sensitized. Choice of control group is you are having a drug. Conventional, you should have a control. The conventional members of subject expert committee will ask, where is the control group? Are bhai, how can I bring control group? So this is again require a paradoxical out-of-box thinking process. And regulatory issues, which are other regulatory issues, I could put them as a 3 C's, but we can put it a 4 C, or maybe you can delete 1 C. Consenting process is much more difficult in this. A child suffering from a rare disease where he has been wandering from one patient to one doctor to other therapy to third system, and then he is getting some benefit or hope of benefit. Now you say, no, try my intervention. Consenting process becomes much more difficult than any other thing, particularly child. Consenting child is difficult, but consenting in this will be much more complex. The control group and standard of care, that is, as I said. And third is the compensation issue. In any clinical trial, if anything injury or clinical trial related problem happens, it has to be compensated by the law. And there is a formula which we have devised it. Now in this case, when you say that this could be the progression of the disease, or when you say this could be the possibility of the intervention, and then he may go to say that the child has deteriorated, now I need a compensation because he is in the trial. So these are the complex situations which we are still not able to solve. And why I am saying these, because by the time, because the country is now evolving and developing new drugs for this intervention, this is the time when we get prepared for this. That's what it is. Due to now, if you ask go to a statistician, your friend statistician will say, I need 100 patient or 200 patient for this to have an adequate N for statistically powered study. Are bhai, puri country mein 100 patient nahi hai. How can I give you that? There may be 2 patients or 3 patients, and now therefore what is appropriate N? You have to have a different type of statistician who has an open mind. Not the conventional statistician. He will never be your friend, he will never be of this science. So he has to have science and mind and the application at a specific situation. So that is what is appropriate N is to establish drug safety and efficacy. Otherwise, no drug will be there in rare disease because you will have never sufficient number of patients to establish the required standard of safety or efficacy. And that is one important challenge. Sample size and statistical analysis plan. This is to be there. Trial stopping rules. It's easy to make trial stopping rule. If I am doing anti-diabetic drug, I found that I planned for 1,000, but after 500 I see it is not causing effect, I decide that trial should be stopped. If this is causing unacceptable side effect, I decide this to be stopped. So there are stopping rules for all the trials. But in this case, stopping rule becomes much more difficult because the disease may progress and the disease may progress lesser and disease may progress faster in spite of giving the drug. And the variability in between of this symptomatology comes. So that is what is also very important. So now it's also criteria for taking patient off. I'm saying you stop the trial. That means you don't give any of this 5 patient drug. But now I say 4 patient fine. This particular patient, if I say you stop the trial in this because he is not responding or not tolerating this. The inter-individual variability of these interventions is likely to be more than any other small molecule because they are no predictable. We have to have a clinical trial DSMB, Data Safety Management Board, which is mandatory for such type, and Data Monitoring Committee. All high-risk trials have these mandatory. But in this, unless these experts are also trained and are understanding the philosophy of this, they will never allow this any trial to go. So that is very important thing. Members need to have deep understanding with broader outlook. Evaluation of long-term safety and persistence of efficacy is also important because it's not like you have an analgesic or you have antibiotic where you see that after 7 days the efficacy, it has to be given for lifelong. And the efficacy may decrease or efficacy may persist. And therefore it is important to vertically follow up these patients for a much longer period. And that can happen only when these studies are supported. Regulator. What's the regulator? Because they need some support from us. Regulator should understand what is the benefit and risk of the drug. And there is a method of assessment of the benefit of risk. And now in this, what is the important thing is that willingness to accept greater risk and side effects, greater risk and side effects, treatment for life-threatening and debilitating disease. That's why in anti-cancer drugs, we accept greater risk. Most of the anti-cancer drugs have higher degree of toxicity, but still we accept. In this case, we have to still accept more because the trials are much more complicated in that. And that's why and the other thing is seriousness of the disease, the unmet medical need, because if you say that this is unmet medical need, the lot of regulatory process is soft. And we, for the first time in 2019, I chaired that drafting committee at 2019 rules, rare drug status has been identified. If a rare drug status is given to a particular drug, in that case, there is an expedited or fast track approval process. But so far, hardly any drug has come to that except 1 or 2. An exemption from clinical trial fees, sorry, I think it is not clinical trials, clinical trial fee, but hardly anything. This is not so big incentive. Also important thing which should be there as a specific, I think I should write, should be separate subject expert committee which is called as a SEC. The conventional expert committee, those who are aware of the approval process, there is expert from biochemistry, pharmacology, medicine, and then for this type of understanding they have to have a much greater understanding and therefore they have to be trained. So that is another challenge. What we need to do, prioritize rare disease. And you can see the list of rare disease, if you see global list of rare disease is huge. So what we need to have, by a consultation process, prioritize the rare disease for India first, not for any other part. First for India, you prioritize maybe 10 or 15 rare disease where we can and motivate the academic researchers. I think the leaders are sitting here, and maybe we can influence that. If they are working on this, they should be recognized much. Academia industry partnership we are talking, because ultimately if you publish, as Sir has said, ultimately unless the industry gets motivated to make it, to upscale it, this will not see the, because ultimately this has to go into the drug process. And use of artificial intelligence is becoming more and more, because you have to derive information, more information from the less subjects. Gone are the days when you have to have a large number of subjects and you derive this much information, which is statistically valid. Now you have a 1 or 2 subjects and you have to derive much larger information, and developing experimental model and clarity on how to develop risk benefit assessment. Now you have also to understand and develop what I call as innovative methods on clinical trial for rare disease. If we do the clinical trial the way we are doing for conventional clinical trial, it will not fast track the process. What could be the important thing? And some of these examples are, which we have done in COVID, adaptive clinical trial. Means we have developed a protocol, but if this drug is not working, I stop in between, I change the drug. If this protocol is not working, I change the protocol, but I need not to change the entire protocol. And that is called as adaptive clinical trial protocol. And that is also flexible clinical trial protocol. I say that now I am not doing 10 times 100 blood parameters. I need only 5, 6, because these are giving less information. So there are several things which are adaptive, which are clinical trial, and which are flexible clinical trial. This is not acceptable by the conventional clinical trialists. So this has to be like N of 1 trial. This is something different. If I have only 1 patient, can I do a trial? No statistician will say, oh, how it can be possible. No physician will say how it can be possible. But there is no patient. There is only 1 patient, and this person is himself is a trial. I give this subject a protocol before and then after 15 days or 1 month or whatever trial, and then you put off the drug or give control, then again give drug, then again control, so this becomes randomized. Patient does not know, the physician does not know, so this is 1 person randomized and double blinded. And this person itself, the evidence generated is acceptable because you have done a protocol, you have done the lot of investigation. So this N of 1 can be for 1 patient or maybe 5, 6 or 10 patients. That is the concept which is now being proposed but yet to be accepted. And we have to bring this concept in our country also. Because N of 1, so this is something I think I have included this in our clinical trial new methods also talk. N of 1 are the double blinded, randomized trial with a limited number of patients, often as small as 1 patient. So people should not say, yaar, iska the patient in here, how can I do trial? Even if you go to ICMR, they say it cannot be done. Find out where are the 20 centers, involve all the 11 centers, center of excellence. There is a method. These trials follow many concepts of randomize, and the N of 1 trial may be especially useful in patients with pharmacoresistant, and this has been done. Pharmacoresistance epilepsy. The epilepsy which is just going to patients who are not responding to any anti-epileptic drug. This is also rare disease. And he's not just going to surgery. Now somebody says that this drug is effective because of XYZ, logic, synthesis. Now he can try on that. So this has been done in that. So in conventional RCT, randomized controlled trial, what it shows, it demonstrates that the therapy is effective in a population. In a population. But here, this N of 1 trial, 1 patient trial, this indicates determine who the therapy works for, that it works for him. When it says that yes, this therapy works for him, then it becomes a case of phase 4 study indicator. Then you do it. Many times we used to condemn, oh, some neurosurgeon or some physician has said that I have treated this patient of rare disease by this drug. We used to condemn. But if this is done in a very protocolized manner, then this can itself become one of n of 1. N means number and 1 trial. That is, so this is, the another thing is patient reported outcome. If there are 5 or 6 patients and they say that according to this protocol, they say that yes, this improvement symptom, this improvement symptom, this improvement. So this patient is reporting, and that is what G and E myopathy has been. Some drugs have been studied on G and E myopathy. So patient reported outcome, the N of 1 trial, flexible trial, adaptive trial, these are the trial of future for rare disease. Role of industry is, role of industry thinks that what will be the price? This is a major apprehension. So now they should, with your support, academic support, should enter into dialogue for pricing or reimbursement policy early before they enter into the final product. Otherwise they will say, we have spent 1 million rupee or maybe 100 million rupee, and this is what it is. And encourage participation of small industry, consultation with rare disease association and experts, and encourage the rare disease network. And finally, the Government of India's these are initiative. I will not go into the detail. National Rare Drug Policy has been framed, and the ICMR hospital-based registry is being made, and DHR has, Department of Health Research has made national consortium, and I think a couple of us are part of that. These are the broad objectives of this consortium, starting from epidemiology to treatment, basically 4 verticals. So I co-chair the few of them. So future prospects, this is just a summary of that. Prevention, I do not know what could be the strategy of prevention of this, whether counseling, marriage counseling or genetic prediction. The newborn screening, which is a part of the government agenda. Early diagnosis, national registry, and finally affordable treatment. And this can only happen, this is what I have suggested to industry consortium when I met it in ICMR. You can create 6 verticals. One is specific enzyme replacement. Ultimately, that is the ultimate, but that is difficult. But we have to work in institution like this. That is one. Biological gene therapy, much more complex. The other is novel small molecules development. This is slightly simpler. The second is active pharmaceutical ingredient, because there are several diseases, drugs which have been identified, which can be made, but we do not have API. And then you make formulation of API. And I just tell you, one disease, sickle cell, which is not the typical rare disease because the number of patients are more, but in Indian context this can be mixed. The drug hydroxyurea was not available as a solution or as a suspension in India till now. It is available as a 500 milligram capsule, and the dose is 10 milligram and 20 milligram per kg for children. For children used to be given by breaking the capsule and giving that. Now this is absolutely unscientific. The capsule and tablet should not be broken. The titration cannot happen, and therefore toxicity will be there or underdosing will be there. And when we interacted with 2-3 industries, one industry said, we will take this challenge, and within 1 year they came out with the formulation and which was presented. So now Prime Minister gave an award to in what is that, Mandap, Bharat Mandap. So recently, because simple innovation, because there was a lack of academia industry interaction. Now, drug repurpose, so that is the third vertical, indigenous manufacturing of API in India, because why we need to come from China or from Korea? That is the third challenge which some of the NIPERs have been now mandated. Drug repurposing is another, and lastly, ancillary management devices. The myopathies, there are a lot of devices which are supportive. So these are the 6 verticals, I say, which the industry should work. And this all can, the war or the can happen when there is a government agencies work together along with academia and industry, and most importantly, this is the patient or group, who are the patient-related group. So they can be a very, very strong support of this research group. So thank you very much, and I'm sure that maybe this is the beginning of our strategic war against rare disease, and we will be successful. And my salute to all of you.
Fantastic talk, and some of the points are really important, like you mentioned, thinking out of the box by the community members. For example, we have institutions, like there are ethical committees which generally cater to diseases, but to work on rare disorders, there should be some guidelines, because there are some different rules that should be followed, like you mentioned. The numbers are very less, how to have control groups and all those things. So, do we plan to have, or do we have, because ICMR has a general guideline for ethical committee, but do we have any such guidelines for rare disease research? Because we are initiating research right now, so it's very important to have those guidelines.
I fully agree, and that's why recently a task force has been created to make a draft, bringing all those points, and once this draft is there, and that's why this is time for all of you to make suggestions. And then once we come out with the draft, and then we'll polish it, then we will submit it to the government and the regulator. But this is something very important. There is no comprehensive guidelines. Once there is a guideline, then there will be regulation.
These guidelines are required at both levels, right? In starting of the research as well as clinical.
Absolutely, absolutely. And
Hopefully we will be able to share it next week.
but I will encourage all of you to send your comments.
So, as you said, the crucial problem is not enough patients in any particular disease or condition, and that's the situation everywhere. Why aren't there more international consortia for making patients part of trial networks?
That can always be an issue. I think that point is very valid, because if you have one patient here, one patient in UK, or one patient in Uganda, can these three patients be part of the same trial? There is always a possibility of multinational, multi-centric trial in this. But it's not that this trial has to be only in India. There is a possibility that you have, and that's why in COVID also, initially few trials are there, which has the South Africa was also part of that, India was part of that. So this can be done.
I think there's an example of DMD where there's an international trial that patients are.
Yeah.
One more question? Is there just a question to you were so aware of what is happening in Stethoscope and drug regulatory. Are they serious about drug discovery and willing to actually make a separate expert committee? And I know what you did in Stethoscope 2019 rules, at least the rare diseases are there now, and there are some concessions. But going beyond making separate expert committees, etc., do you think it's going to happen?
Not to be recorded, but serious, you see, these are the regulators, and they are hesitant in applying their dash. So they basically go by what is written, and they say that applying mind is not our job, that is your job. And that is why any initiative which should come from the standard regulatory system is lacking in India. See, in US or anywhere else, you see there is a scientific wing of regulatory system. And here they depend on few experts, SEC members or like that, which are neither adequately knowledgeable nor they come prepared with the background, and that makes something. But person like you, Dr. Rakesh, and you, when there will be pressure from the through the government, the regulators move.
Okay. Okay, with this word, thank you very much.
Delete this. What?
Live streaming. Lovely talking about it. Now we have our next program, panel discussion. And we'd like to invite panelists. It will be, convener of this panel is formerly from CCAP, advocacy. And then we have from IDAB, and she's in this area of policy, etc. And I've been working with them, including their. Then we have from patient organization and then we have scientist and also from the patient organization called World Health last is Professor from NCTS. He's a clinician scientist who actively involved and has a very interesting scientific story of how they have actually worked through a possible treatment. And
for introducing everybody. So I request. Yeah, okay. And I would like to thank the Academy for accommodating us and arranging this event. Thank you, Professor Indian, for helping us out this. I just want to say one disclaimer that I was given undue credit. I have done very little in this, all thanks to Alok that all this issue has come out and all the work I did whatever little bit. And I thank Professor Gupta for coming and actually setting the stage right for the discussions. So many things, maybe a little bit, but they seeing this in one go and giving your insight. Although you throw the challenge of enormous size, but I think you also gave the hope that if people like you are there to guide, I think we can succeed. And we have a fantastic panel. Again, I am the least qualified here because my research is very different kind. But I represent Tata Institute for Genetics and Society, whose aim is to use high-end science to solve societal problems. And this is a unique thing of this institution is this is a program-driven institution and not PI-driven. And our aim is to solve problem and not to publish papers. Publishing paper is collateral. Maybe it's a little bit awkward to say in this where we are releasing a journal, but that's what our aim is to solve the problem. So I think there, and we have been getting so much of support from wherever we have been trying to do because people are now interested. Particularly, so we work on crop improvement, rare genetic disorders and infectious disease. We have 3 programs. And in rare genetic disorders, I am very excited because all the challenges that you showed, there is some hope at least from a technology point of view. And I think that it's not totally absurd to say that we expect diagnosis not to take 4-5 years. It should take those many months or maybe even in weeks because we are reaching the AI, we are having the technology, DNA tests are now really affordable. Sequencing is becoming so much more affordable. So we expect that kind of thing to happen. We also expect more awareness so the new technology, new solutions are acceptable to society. We have to work very hard for that. And also the new treatments that are emerging using CRISPR-based technologies and in vivo gene therapy. These are things, they are going to be really really affordable, and I think even out of the pocket people will be able to afford in coming years. At least science is giving a promise. Now Professor Gupta already showed what the challenges in parallel the regulatory and other social acceptance we are facing, and I think it is basically the responsibility of scientists to spread the message of science, convince people. Everybody wants solution, but we have to, which is our responsibility to make this happen. And we have seen how quick progress can be made when we take things seriously, we are focused, where you take diagnostics of the COVID or the vaccine, so fast it came, so why not for other things? And again, Professor Gupta mentioned that we are excited to do science because something intellectually very challenging enough. But people who are associated with this kind of research for rare genetic research, they also have their heart and feelings associated with it. I think that brings us the special thing, additional component of, and that I think makes me feel that we will succeed sooner than regular process of this. I think with that, I would now request our panelists to maybe in their domain of expertise, take maybe 5 minutes or something and say, and then once we go this round, and all of you are panelists, so there are many, even more competent people on the other side, so all you can contribute, and we start fruitful discussion. So Gayatri, I go with you first.
Thank you. I was asked to provide a brief outline of the latest policy which Professor Gupta has already mentioned, and I hope my colleagues will do so. Okay. So, and especially for students, I would just like to clarify things those who are experts already know. A rare disease, we also include a rare condition, not necessarily a disease. Right? So, as Professor Gupta mentioned, there is now a national policy for rare diseases 2021. There was an earlier one that was given away, so that's the one currently. And as you also mentioned, we don't yet have a definition for rare diseases in the country. And it's hoped that as the registries are built up, the data is collected, that will help us to come up with a definition for our country. And that's always important. So just to mention, we actually not have heard, like, what are we talking rare diseases, right? So there are primary immunodeficiency disorders, lysosomal storage disorders like Gaucher's you might have heard of, small molecule involved errors in metabolism, immune disease, etc., cystic fibrosis, certain muscular dystrophies, spinal muscular atrophy, etc. These are some of the common examples. Now, although we don't have a definition for the country, this policy has divided the rare diseases into 3 groups. So the group 1 are those which are amenable to one-time curative treatment. Okay? So for instance, an organ transplant. We do the organ transplant and then now the patient is cured. The second are those which require long-term treatment but which are relatively affordable. So again, there's been some reference to how expensive these are, but no hint of what is expensive. Expensive can mean 2 crores a year or 12 crores a year. These rare disease treatments are something stratospheric, okay, in terms of the cost. There are historical reasons for that, but that's a fact. So even in India, for instance, there have been these crowdsourcing efforts where people have managed to get 2 crores, 12 crores. Unbelievable. Any random couple has this child, and they are simply tasked with having to raise this enormous amount to save their child. I mean, a few accidents. So those are called the group 2. And the group 3 are, yes, treatment is available, but they have very, very high costs. Right? So in the policy, as far as I can make out, the policy has not touched group 3. That is so challenging, like how to fund that, but they have addressed group 1 and group 2. Okay. So these 3 groups currently cover about 50 rare diseases. Okay? It's known that there are roughly 7,000, 8,000 rare diseases in the world. I think in our country, I'm aware of some 450
maybe that figure is slightly outdated. It is known that at least one patient of about 450 cases have been identified, but maybe 50 are those for which some treatment, and sometimes the treatment is not just a drug, it could be a special diet, right? So that some modality of treatment / management is known. Okay, so I come down to the strategy of the policy, what the government thinks is, how should we go about it? So one is this hospital-based registry, like Professor Gupta mentioned, ICMR has one, right? Where it would have a database and data on each condition will be collected as you encounter patients with this issue. And now that becomes your data, on which to think about the issue. So again, awareness. One of the primary kind of thrusts of the policy is let us create awareness, so that treatment can be sooner, but also to avoid the birth of children like this. If there's no treatment, then the best thing is to avoid the birth of such children. So, as you mentioned, it could be awareness amongst doctors, awareness in the public. Either a child, a particular couple does not get married because they each are carriers of something, or preconception, or as soon as possible after conception, or after the birth of the child, as soon as possible, diagnosis, and therefore treatment as soon as possible. Okay? So, and the central government will also support state governments in screening and other awareness. So, the government has said, Government of India, that it will provide financial assistance up to 20 lakhs to patients who have group 1 problems. Okay? So, you can imagine 20 lakhs for one patient. And that's one of the lowest cost things, right? And state governments have been encouraged to deal with group 2, right? Including these foods for special medical purposes. Then they have notified certain centers of excellence, as mentioned, and those centers of excellence will receive a few crores each to help roll out programs, and the programs will be education, training, screening, diagnosis, research, etc. Then the issue of costs. So because some of them are so expensive, and realistically speaking, the only way to bring down costs in this country is to do local R&D. As soon as something is done locally, the costs come down, or of course if you make a generic drug. So that has to be a component of any policy to handle rare diseases. For that matter, even other diseases where we have no genetics. So the government has proposed an enabling environment both for local manufacture and for R&D. And that research includes repurposing of drugs, which means you already have a drug for disease A, but you do some experiments to see if it will work for another condition. So it exists already, so the price is already somewhat affordable. If it's generic, you're the policy does encourage international collaboration for research. And again, as mentioned earlier, possibly the need to modify clinical trial norms to handle this particular situation. State governments have been encouraged to set up one department of medical genetics, and at least one in a medical college in the state, so that people don't always have to go to Delhi or to other places for care. And the Ministry of Finance will be requested to reduce custom duties and generally help to make it more affordable. So this is a very, very brief briefing on what the policy says.
Thank you. Thank you very much. You can give to that. The only thing, I think now in the revised version, this is 50 lakhs, not 20 lakhs. So that is created. But still, that is very inadequate. It runs out very quickly.
Sure.
So our next speaker is Ramu. So he's working on doing research on syndrome and the other diseases, and we interact often, and that will be very fast.
Thank you, Rakesh. Can everyone hear me? Okay. So just before we came in here, Rakesh informed me that I have to speak both as a clinician and as a researcher. So I'll try to do that. I think that first of all, from a clinical point of view, all of you have at some point or the other been unwell. And when you are unwell, the next best thing to being treated is to at least know what is wrong with you. And therefore, the ability to be able to diagnose a patient with a disease offers some level there's often in the minds of, for various reasons in the minds of governments, regulators, so on, this notion that for a disease to be important, a large number of people have to be affected by it. We are very easily impressed by statistics that X number of X million people have a disorder, cancer, diabetes. But it's very essential that each of us place ourselves in the shoes of the patient who has a disease and also their carers. And we should all take a moment to remember that it doesn't matter if the patient sitting in front of you is the only one that has a particular disease. It's very important for that patient from a clinical point of view. They have a diagnosis. We also find some solution. So this is from the clinical point of view. From the research point of view, there is somewhat of a notion that because the disease is rare, there's somewhat of a notion that because a disease is rare, it's surely easy to quickly find a solution for it. But whether it is diabetes or cancer or any one of the many rare genetic diseases, biology is complex, and the biology of a rare genetic disease is just as complicated as that of diabetes or cancer. So as scientists who work on it, and as people who expect scientists to find solutions to rare diseases, we must be respectful of the complexity of the problem that we are dealing with, and we must, of course, also put in equally strong effort to find a solution. Dr. Gupta has spoken at various points during his talk about both measuring rare genetic diseases as well as understanding them. The famous German physicist Max Planck was fond of saying that understanding must precede application. And if you look up the Max Planck Society website, this is the motto of the Max Planck Society. So understanding must precede application. So we'd all like to quickly find a cure for a disease, but I think it's always better if that cure is based on an understanding of the disease and how the drug or treatment that we are proposing is alleviating the symptoms. I'd just, in a couple of minutes, like to bring out a historical thing. Maybe Dr. Gupta is the only person who knows the name of James Wingarden. He was a researcher in the United States at the National Institute of Health in the late 70s and early 80s. He is originally famous for having worked on inherited diseases of purine metabolism, primary gout, and he did a lot of the work to understand a disease called Lesch-Nyhan syndrome, which is a self-mutilating disease arising from purine metabolism. And he wrote a very famous book called The Metabolic Basis of Inherited Disease, which you often find in medical college libraries if anybody goes to a library anymore. But what Dr. Wingarden was very famous for was that he was the first person in the United States and in the National Institute of Health to emphasize on careful documentation of a rare disease at multiple levels, ranging from clinical features through to the underlying biochemical disorders, be it measured in blood or tissues and so on. And if you read the original editions of Wingarden-Smith's Metabolic Basis of Inherited Disease, there is a very analytical framework given for every disease that allows clinicians to arrive at the correct diagnosis. And many times, the interventions that were designed, be it modifications of diet or so on, were not based on a knowledge of the underlying gene, but on a knowledge of the underlying biochemistry that was detected in blood or peripheral tissues. Of course, when Wingarden was working, there was no human genome. Cloning a gene was many decades worth of work, and there was no particular database to go and look up anything. So I just wanted to use as example to illustrate the fact that although gene therapy may be an ultimate goal of many things, it is possible to find solutions to metabolic diseases that are based on what on his slide was mentioned as the use of small molecules, modifications in the diet or treatment that exploit the underlying observations about altered biochemistry for the benefit of patients. Since we are talking about rare diseases and how government should respond to them and so on, James Weingarten went on to become the director of the National Institute of Health in the United States in the mid-80s. And he was the one who first proposed the use of evidence-based and analytical approaches to understanding diseases, and it had become a feature of evaluating and funding grant proposals by the NIH in the late 80s and early 90s. So I think these are all some aspects of both the clinical and the research perspective that perhaps we should bear in mind. Some time ago, there was a committee meeting of one of the national agencies had a funding meeting, and there was some discussion about a proposal that was about a rare genetic disease, and a very senior person on this committee shot down a proposal saying that not enough people suffer from it to be worth funding it. If that sort of approach prevails, then it's unlikely that we will make a significant dent going forward. And in the domain of policy, Gayatri's also mentioned it briefly, we will need to change our mindset about how we think about rare diseases if we are to make a big dent in it in the future.
Thank you.
Just wanted to make one point. In this issue of India is one of the first, I think we were the first ones in this country to identify lysosomal storage disorder. The history of that discovery is in this issue by Professor Bimal Bachava. You must read that story, how, what Raghu was describing, how basic biochemistry was used to identify. It's just that it happened that we have not.
Thank you. So Sudha, she represents the patient group and also biology professor.
Thank you. First of all, I'd like to thank the Indian Academy of Sciences and especially Rene for the interest that they've taken for rare diseases and bringing rare disease research landscape in India in the limelight. So I really hope that this would be the beginning of more Indian scientists coming into rare disease research. So I'll be speaking for a few minutes as a scientist and also as a caregiver of a rare disease. So I would like to highlight the importance of time when we are trying to discover therapies for rare diseases, because rare diseases are almost all of them are progressive, and the patient is becoming worse every day, either moving towards fatal outcome or towards severe disability. So either way, they are waiting for something to come, whether it's a cure or treatment, or even helps them to manage the disease in a timely manner. Although, I do understand and I really appreciate that research in nucleic acid-based therapies has to be given the first priority, because that has the chance of actually probably coming down as a cure, whereas all the others would be only treatments or managements. But nevertheless, as I said, that time is of the essence, and nucleic acid-based therapies, as we all know, are like work in progress. They are going to take time to come to the patient because of the very complex issues involved and also the high cost. So meanwhile, we must look at rare diseases in a way that we can provide some kind of treatment options to the patient, And when we look at rare diseases, although a particular disease is rare in the sense that whatever definition we use, the number of patients is going to be small. But we can see that if we look at the range of diseases that we are looking at, the particular gene involved may be different, but a lot of genes may converge into a particular pathway. So what we find is that patients suffering from a variety of very different genetic genes mutations, and even the organs of the body affected may be different, but the underlying biological pathways actually tend to converge. For example, autophagy is one pathway which is affected in quite a range of diseases. So if we are trying to be able to find small molecules that can either induce or suppress autophagy, then we could solve some of the problems, like the fact that these are rare and the number of patients is small. But if we can find a molecule that can treat a number of them, not just one particular disease, then maybe we can attract more pharma companies to come in with products that may not cure the disease definitely, but may be able to treat and provide some kind of relief to the patient. So another example I can give you is that because I work on GNE myopathy, which is a muscle disease, and a number of these myopathies are because of protein misaggregate, formation of misaggregates of proteins, which are actually very similar to like Alzheimer's. So in Alzheimer's disease, we find that there are aggregates with proteins like the phosphorylated tau or TDP43 and beta amyloid. Some of these proteins are also found in the aggregates in muscle disease. So the organ affected in Alzheimer's is brain, but the same aggregates can affect the muscle. So again, we can look for molecules that can target these aggregates and then provide relief to a variety of patients. So these examples I'm just quoting so that as scientists, we can try to look at these pathways which may be affected in more than one rare disease, so that we can then attract pharma companies to work on these. And as everybody has mentioned about repurposed drugs, so I think in India should really take a lead in repurposed drugs. As we know that even a drug like metformin, which is such a common drug and used by so many number of people with high safety and toxicity levels, we know that even metformin can work as an autophagy inducer. So it would be worthwhile for India to take a lead with repurposed drugs if we could set up clinical trials for some of these molecules which are known and tested to be of less toxicity for human use, but they need to be evaluated. So right now the evaluation is being done, but at a slow pace and definitely not in the Indian population. So I think we in India should try to push that, because that's a relatively inexpensive way to provide some drugs to rare disease patients. So I would like to highlight these issues. And then also I would like to say that the clinical preparedness that we need to have while waiting for the drugs to come out, we should be clinically prepared to provide the drug once it comes out. And as Dr. Gupta has mentioned really brilliantly in his talk, we need to have cohorts of patients of rare diseases, because the numbers are always going to be small. But it's not that in India we definitely have very, very dedicated patient groups. These patient groups, along with the clinicians who are treating the patients, have actually informal cohorts of patients. If these can be formalized, then we in India should be able to perform natural history studies and try to understand disease progression before the drug comes out. Because these natural history studies can take 2 to 5 years, because these are slowly progressive diseases. So if you want to have a good idea of disease progression, and what can be the endpoints to be used, as Dr. Gupta pointed out, that what endpoint will you use to show that a clinical trial works. So if we can start those processes right now, today, then we'll have the data with us after 2 or 5 years or whatever time it takes while the drug comes out, so that we can do a meaningful clinical trial. So these are the issues that I would like to highlight to be able to buy the time which is very crucial for our patients. So we can discuss more further. Thank you.
Thank you. Thank you, Sudhafar. Our next panelist is Mr. Madhur Gopal, and he works for RGI. Terrific job he does there. I saw him the other day on Sunday during the race for 7, and he was really managing the thousands of people. So your views and from patient viewpoint.
Thank you, sir. And good evening, all. I represent ORDI, Organization for Rare Diseases in India. We are a national organization representing all the rare diseases. And I would like to tell you how we work. We have divided our portfolio into 4. One is definitely the patient support and patient care, where we tie up with the hospitals. We work closely with hospitals like AIMS and NIMS. Then in Bangalore, we have a daycare center from 2016 in IGICH, Indira Gandhi Institute of Child Health, which is the Asia's largest ERT treating center, and we are in collaboration with them. We work with Baptist Hospital for nerve and muscle clinic, exclusively working on neuromuscular disorders. We have even tied up with private institutions, charitable institutions like JSS in Mysore, specifically to identify patients from the tribal and rural community. And this is on the patient support. Along with that, we do some fundraising, which is part of any NGO. We provide a lot of equipment, especially in case of rare diseases. 95% of rare diseases do not have any kind of treatment. So the standard of caregiving is one of the methods to actually ensure that the quality of life of the patient is taken care. So we provide BiPAP machines, patient monitoring system, build an in-house ICU at their homes, and many other things, a smaller even payment like, attenders payment or even physiotherapy. This is on the patient support side. Third is awareness. Recently, as sir said, we concluded one of the largest rare disease awareness program across the globe. We conducted marathons in 15 cities in a single day at a single time, flagging off from Bangalore city, where we had close to 10,000 people supporting the cause of rare diseases. Apart from this, we continuously have these disease-specific awareness programs, CMEs, to engage doctors and other KOLs to ensure that the continuous knowledge is imparted to the right stakeholders. Then we have the last, I cannot say last, this is one of the strongest pillar for us, because this pillar moves us from helplessness to hopelessness. It gives us that hope. So this is the pillar which we call it as research and development. ORDI has been continuously working with various research organizations, and we are honored to have TIGS guiding us. We conducted 2 redress programs in 2022 and 2023, and we have seen substantial research papers coming in for rare diseases, and few of them have been moved forward also for further scope to get drugs for the rare disease patient in India. Then we have recently signed up an MOU with National Chemical Laboratories, Pune, to develop drugs indigenously in the country. Similarly, we are working with a few IIT and research scientists where they are specifically working on certain disease conditions. So in the research and development, what we play a role here is, I will just take few minutes. Recently, we had this patient interactive session in one of the clinical trial companies. We had few patients coming in. One of the patients said, "You are all here, you are all knowledgeable people. I am suffering from a disease which was misdiagnosed. She is suffering from LGMD. She is wheelchair bound, she can't move her arms, she can't move her neck, completely wheelchair bound. She was misdiagnosed for SMA when she was somewhere around 13. But it was LGMD. There is no treatment anyway. She said, this has to end with me. My next generations should not take it, because we are in the era of Jai Vignan. That is what we proclaim as a country. And all of you are here. You help me out." It is not her voice alone. It is the voice of the entire rare disease community, because they don't want to pass it on this to the next generation. And the only people who can do it is the research people, the scientists. We have one more or a couple of other cases also where how we get these kind of patients is that we have a rare disease helpline since 2014, since inception. We get calls from patients, we get calls from genetic counselors, we get calls from doctors also, and we register the patients. Once we register, then we try to help them out with navigating through various channels, like who's the doctor, where the treatment can be made, is the treatment freely available. Like how ma'am mentioned, there are around 50 disease conditions where the government of India enrolls them and gives them treatment. We recently received one call from Idukki in Kerala. It's almost like 7 months ago. They are not able to actually find their fingerprints, a particular family. Now, how it affects is, he cannot take an Aadhaar card, he cannot write UPSC exam, he or she, or they don't even get bank accounts. We immediately sent our genetic counseling team there, also to collect some samples to find out what it is. We collected one sample, then we realized there are 53 others in the same vicinity who are suffering from similar kind of challenge. These are all contributing citizens. They don't have any other disease. We will be losing them if we don't treat them, right? So we will be losing their services just because they don't have fingerprints. We collected them, collected the samples, sent them to CDFT. The research is going on. We have a MOU with CDFT and work is on. These kind of challenges come to us every day. What we think is small is not small. In Chamarajanagar, we had one similar kind of challenge, which is a dermatology issue. Initially, it was thought that it is something related to the water, something related to water contamination. Then after a lot of efforts, we realized that it is not water contamination, it's a genetic disease. We thought it is in just one basti kind of a place, but almost like 3 to 4 large villages are affected with similar kind of disease. Few were aggressive, few were actually affected very badly, but few were actually having those symptoms. It might be late onset as well. So where we are looking at is, the challenges which we are seeing are not just genetic or anything, it is a social issue. It is a larger social issue because we are talking about 70 million patients affected in the country, which is larger than Karnataka and Goa put together. And with researchers and scientists pitching in and bringing in something immediately only will help, rather than doing anything, looking at the Western nations to help us out here. Because just for a nutrition kit, which is actually free of cost in UK, to import it, it is 27,000 rupees in India. Just to import it, which can be developed locally here. It is just a small, food supplement which a researcher should, try to formulate and give it to us. And we have to give it to, those children who require it 4 tins or 5 tins every month. So I'm just giving you a perspective of, the challenges which we are facing. So again, I am saying that, we are helpless, but we are not hopeless. Because we see, that hope in all these scientists and researchers who are working actually. And, Redress is really, one platform which is actually bringing out a lot of, hopes and, to working together.
Thank you, Madan, for you're doing tremendous job in service and it's motivated. So in each redress we bring patients for this to interact with scientists and clinicians and others so that we get sensitized. So we'll be have to close soon, but if there are questions, yeah, Ravi.
Thank you so much. My question is to Sudha. You spoke about opportunities where repurposed drugs could be one way forward, and you used particularly the word push. So I'm trying to understand that if you develop a model for a rare disease and find ways of identifying approved drugs for other treatments, now working, let's say, effectively in such a model, what is the gap now we are seeing from going from there to even trying out on a clinical thing?
Yeah, so that's a really very important issue. So, for each rare disease, the model system is going to be its own, So, it could be a cellular model or an animal model. And the problem comes there because the models most often don't replicate the human disease. So, but whatever is the best model available, nowadays cellular models tend to be more used. Then the issue would be to try and, use those repurposed drugs with the available cellular models and see whether it has an effect or not. Because now if I'm using a panel of repurposed drugs, then, I can test in one go a lot of them on my model, whatever. If it's a cellular model, it's much easier. It can also be done with animal models. So let's say that I test a panel of 20 drugs and I find 1 or 2 molecules which are in my model showing very good efficacy, then I don't have a problem of toxicity because that we already know is very low. So now I should be able to run a clinical trial like Dr. Y.K. Gupta has shown that, even expedited trials are allowed for rare diseases. So I can actually be able to run a clinical trial in a relatively short span of time with those selected drugs. So that kind of an approach is required. I don't see it happening yet, but I think we can, hope for it.
I don't know whom I should address this to, but possibly it is to clinicians or to people who are setting up medical colleges, because I think that when we're talking about natural history of rare diseases, we should also be training our young medical students to be, receptive to looking at, things that don't fit particular boxes. It's not clear to me that our present medical education is really geared up for, training our young people, young medical doctors. I know that we've been addressing researchers a lot in this panel discussion and whatever. But I think what is the role of, good medical education in helping this problem? So maybe somebody wants to.
I was in medical school a long time ago, but I try to answer it from what I remember. Typically, the kind of textbook that I mentioned is used at the MD and DM level for teaching. But in undergraduate medical education, in my time, about 1.5 years was spent in so-called basic sciences, which is anatomy, physiology, and biochemistry. And that's medical education system in India is not, in my view, geared towards analytical or evidence-based thinking. Most of it is about learning the facts and being able to reproduce it at the exam. But there are exceptional places which do train students well. There is also a lack of connect between the basic sciences and the clinical sciences, and much of our understanding of clinical problems, including rare genetic diseases, will be based on anatomy, biochemistry, and physiology. And then when we get to second year medical school, pharmacology and pathology are added to the picture. So I don't particularly think that the education system for medicine is based on a research mindset. It is just based on training people to go out and see patients and so on. We will need to introduce some form of thinking-based approaches in early undergraduate medical education, because the sort of thing that you're talking about is not really about diagnosing a disease which is already well known, but it's about diagnosing or finding a solution for that large group of diseases where they don't clearly fit into one or the other. One particular problem with many genetic diseases is they are often suffixed with the word syndrome, and the word syndrome implies a group of symptoms and signs that come together, and then is usually named after whoever described it. There is therefore clearly an overlap in biology between different syndromes, and that's not the sort of thing that medical students are trained to deal with. You are trained to diagnose what is accepted in the textbooks. So dealing with uncertainty is not something that happens in medical school. But I shouldn't probably speak too much more about it, but Dr. Gupta should.
Yeah. You want to say something? Or?
Sorry, I did not get the question which you said.
No, the question that was posed was, what, if any, should be the modifications or changes in medical education to sensitize doctors being trained or medical personnel being trained to the problem of diagnosing relatively new and unknown diseases?
A difficult question, because when we say in MCI, our primary objective is to teach and train them into common diseases in India. That's the primary focus. But critical thinking must be inculcated in these, so that they must have a skill that when to refer, not to treat. When to refer is the most important skill they should. They should be skilled in that. So that's it. We don't want to make an MBBS expert in rare disease. It will be a disaster. So we must honestly train them when to refer it to senior, to different.
So I'm just wondering, I mean, I'm not a medico, whether instead of even talking about specific rare diseases, the phenomenon of rare diseases, right? So if that awareness of phenomenon, and then as ChatGPT is answering many of our questions, not all, and so, okay, put it in, get an idea, you're not going to treat it, but at least you get maybe this is a known thing, and therefore maybe there'll be a database of doctors who treat or whatever, so that you're only following a process. You're not actually treating the patient yourself. But just the awareness. Many may not have heard of rare diseases, right?
This is exactly what we do. We have a number, and we have people try to reach us we have an in-house doctor who does this job. She is not a geneticist, she is not a trained rare disease professional, but she knows whom to refer to. So that is taken care of, because from there it navigates.
Thank you. Okay, so Mahesh, okay, last question, because we are running out of time. Yeah.
MD PhD program in our country, where
not yet. I don't think there is any MD PhD program, but I think it. At least in AIMS, this is not there, but ISC and KG Medical College started MD PhD program, but there were few takers in the beginning. But unfortunately, we tried to push it. But it's difficult because the people just after MD.
Long time back, CCMA, NIMS signed an agreement, nobody came. Yeah. Really, very quickly, because we are running down.
Myself, Dr. Banu Prakash. Sir, actually, my question is to you, sir. I think in medical school, the more affordable subject I believe is preventive social medicine. So, what are the preventive aspects of these rare diseases, sir?
Well, probably the best way of thinking about prevention in the case of rare genetic diseases is after a firm diagnosis has been established. Once a firm diagnosis has been established and the inheritance pattern is known, there is a very important role for genetic counseling in preventing future incidents of the disease. While that is obvious, it's not something that is, I think, available enough across the country. And genetic counseling is not something to be undertaken lightly and without appropriate training. Genetic disease is not just a disease of an individual, but it's also a disease of the family and society. And there are many social implications of calling something a genetic disease. And therefore, it is very important that we invest sufficient effort in building a group of people who are well-trained genetic counselors who can do this both effectively and sensitively to a family that has just discovered that it has a genetic disease. So it is not a cheap solution, but it is an effective solution in preventing future instances of the disease.
Thank you. Thank you. All the panelists have been terrific, and the purpose was to trigger thinking and discussion, and I see it happening. So thank you all very much. I hand over to Alok.
Thank you, Rakesh, and thank all of you. A lively discussion. I think we sort of followed or covered most of the areas which are problematic in rare diseases. Anyway, so we have a fascinating talk by Mr. Prashant Reddy, and he's just different. He's neither a clinician, not a scientist, and he's a lawyer who has been working in the area of drug policy, and he's an author, he's written some excellent book, and I don't know if some of you have read his book on Truth Pill. So Prashant is, I want to go over your career. He has a master's in law from Stanford, and currently is kind of fully working in this whole area of drug policy. So he's going to tell us about, because it's such an important topic for us, drug policy for rare diseases, that we thought that it would be an ideal to end our symposium.
Thank you, Professor Bhattacharya, for the introduction. I'm just setting the timer so that I don't go over. board. Thank you for inviting me here to talk on how to make rare disease drugs more accessible to Indian patients. As a lawyer, I was really fascinated to see the proceedings here today. Conferences involving lawyers and law students tend to be a lot more cynical. It's great to see how optimistic and hopeful, conferences with scientists are. So with those few words, let me get into some of the basics on how drugs are actually priced. Now, the honest answer to that is no one really knows, apart from the pharma company which is setting the price. But there are a few studies and there's some anecdotal evidence to suggest how exactly prices are set. I'm talking about just conventional drugs, not drugs for rare diseases. So one of the criticisms of the pharma industry has been that they set the prices of drugs just like, Coca-Cola would set the price of a soft drink. That is, how much do they think a person is willing to pay for the benefit that they're deriving from consuming the product that is being sold by the company. Now, in the case of life-saving drugs, that could be a very expensive price because, if a drug is saving your life, then the price theoretically can go into infinity, right? So we saw there were some shocking instances, say about 20, 25 years ago, if you remember a drug called Glivec, which was used to cure chronic myeloid leukemia, where Novartis was pricing the drug at $80,000 a year, right? Now, the other factor that pharma companies will look at when they're setting the price is how much, so not all medicine is path-breaking and new, right? A lot of times there will be medication which is just going to offer a slightly more incremental benefit over what's already there in the market. So the pharma company will just look at what exactly is the competition out there, and they will price the drug based on that. So for example, if there is a medication which requires the patient to be hospitalized for 5 days, they're going to calculate, okay, if he's going to spend, X amount each day in the hospital for 5 days, then I can price my drug, say, about 10-20% lower than that if it's one of these medications which a patient can consume in the house in a pill form. So they're basically looking at what is the competition out there, and they will accordingly price their new therapy at that cost to pitch it as an attractive alternative to doctors and, more importantly, insurance companies in the West. So insurance companies have a huge say in what drug prices are going to be. Government insurers, that, for example, in the UK, you have institutes like NICE, which basically have to sign off on drugs that are going to be prescribed by the National Health Service. So insurers can have a role to play in what drug prices are fixed at, and they have some amount of bargaining power because it's collective bargaining, right? The insurer is representing entire groups of patients together. So there's some negotiation that goes on at that level which determines what a price can be. Now the problem generally for drug pricing in a country like India is when, say, a Novartis or a Roche comes out with a breakthrough therapy in the West, they are going to price that drug for the Western market, keeping in mind what are incomes and per capita incomes and health insurance policies in the West. So once you price a drug, say, at $80,000 in the US or Europe, which may be affordable in those healthcare systems with those kind of insurance policies and per capita incomes, is completely unaffordable in India, even if you're upper middle class. It's going to be extremely difficult, especially because so much of health expenditure in India is out of pocket. Now, a lot of pharma companies have been quite late in realizing this, because it also depends on the internal corporate culture of some of these companies. So a company like, say, GSK, which is a British company, seems to understand India a lot better. Merck, they understand India a lot better. Swiss companies just don't get it. So they were charging astronomically high prices, and their sales actually weren't that great. I mean, all of this is anecdotal data because there are no proper studies. But we've seen cases, for example, like with Herceptin, there is some anecdotal data to show where the price of the drug dropped a little bit, the uptake increased quite a lot. And this kind of price elasticity for cancer medication should not be there in any just society. But clearly, Indian patients are very sensitive to how drugs are priced. And there has to be fair to Big Pharma, as much as we can be, they have changed a lot of their pricing policies in India, realizing that India is basically, as any retailer will tell you, it's a volumes market, right? You just have so many people that you need to make money off larger volumes, lower profit margins than the other way around. So they have dropped their prices. It's not all affordable still, but it's definitely more affordable than what it was perhaps a decade or 2 decades ago. The problem now for the pharma company is, if they are selling a drug for $80,000 in the West, and they're selling that same drug in India for $500, there is a reference pricing backlash, where the politician or US senator is going to ask them, what are you doing? Like, if you can sell this drug at $500 and still make money, why are you pricing this drug at $80,000 for our patients? So these are the complexities of pricing in the global market, especially in the globalized market. And pharma companies are evolving new strategies. So now they license off their patents in India to an Indian company, tell them you manufacture, sell it under some different name, and hopefully that takes a little bit pressure off them in their home markets. Now, as a country which is a net importer of patented medicines, by patented medicines I mean the underlying technologies, even if we're manufacturing them in India, the technology we're still importing it from abroad, there's comparatively less leverage the government has over the pharma industry on how to determine prices. Now, as a result of which we've seen, say some of these therapies which cost $1 million or $2 million or say $1 crore in the West, and they're selling them at the same price in India, the manner in which the battle has played out in the policy field is that we've seen patients go to court. In this case, I think most of them have gone to the Delhi High Court and said that we can't afford this medication, and the government has to provide us with this medicine. And the courts have passed orders to that effect. The problem, however, is that all these orders are legally very tenuous, because there is no such fundamental right to health in the Indian Constitution. There's something called, in Article 21, the right to life, which has been broadly interpreted. But does Article 21 and the right to health as interpreted under Article 21 also mean that the state has to necessarily pay for your health care? That is a rather unique interpretation, and if I may add, a very populist interpretation on part of the judges. Because as Dr. Gupta just pointed out in his speech, you can tell AIIMS, give a medicine to this, to this patient, which is about 1 crore or 2 crores, and that may be more than their procurement budget for certain therapeutic areas. And therein comes in the problem also of distributive justice. That is, if there are limited public resources, how are we supposed to spread those resources across a population? For example, does a patient, say, with cancer, which is not a rare disease anymore, right? A lot of different forms of cancers are not rare diseases. If that is a therapy that's a lot of cancer drugs are very, very expensive. So if a cancer drug costs 50 lakhs, and there is a rare disease, drug which costs 50 lakhs, right now, under the policies that we have in India, the patient with the rare disease is assured some amount of support, up to 50 lakhs under the new rare disease policy. But if you have a treatable form of cancer which also costs that much, there is no such assurance from the government that you are going to get that particular amount of money to be treated. And which is where this gets a little bit dicey, when the courts start interpreting laws, the Constitution in a way to direct the government to spend certain amounts of money. How are you going to tomorrow then justify denying similar treatments to other patients? So approaching this through the judicial route is a minefield. And we need to be very careful because distributive justice is always a tricky issue for most countries. And we need to, if in a resource-strapped country like India, where we have limited resources, arguably even for health, we need to be careful on how we formulate policies. Ideally, we want policies which maximize benefits for the most number of people. So, for example, you're building public hospitals, or you're having a universal health insurance program across the board for everybody. Those may be more efficient ways to deal with these kind of competing moral claims for distributive justice. I'll come now to the second problem generally that most patient groups criticize when it comes to cost of medicine, and that is patents. As you know, a patent is granted in exchange, as a recognition, and it's basically a social contract with the inventor that once you invent something new, you disclose your invention to the general public. The state will give you a monopoly for, say, a period of 20 years. You can charge whatever price you want to during those 20 years. And after 20 years, the technology is available for everybody to use. Now, obviously, if you give any company a monopoly over a particular product or a drug, they are going to charge as much as they can charge. 9 out of 10 times, they will justify it, saying that we need to recoup our R&D expenditure, etc. We have no way of knowing what exactly that R&D expenditure is, because again, these calculations are very complex. They're covering failed projects, the risk that they took, etc., etc. Now, the one safeguard in Indian patent law, or most patent laws, is compulsory licensing, wherein you ask the government to basically license the patent at a rate fixed by the government to competing companies to manufacture a copy of that particular patented drug at a much lower cost. Now, this is something that we have used in the past for some cancer drugs, have been used for AIDS drugs earlier. And it is, there are 2-3 considerations that need to be taken into while making such decisions. The first is whether you have companies in the country, pharma companies in the country, that possess the reverse engineering skills to copy that particular patented drug and manufacture it. So with Indian pharma companies, they have pretty good reverse engineering skills with small molecules. It gets significantly more complicated when you talk about large molecule biological drugs. That's where it gets tricky. So even if you can issue a compulsory license, if domestically you don't have the manufacturing capacity, it's basically pointless. You're still going to be depending on the foreign pharma company to export its product to you, right? Now, the other criticism generally about compulsory licensing, what the pushback that comes from the pharma industry is that when we put in all this money and effort into developing this drug, if you're going to break that patent and give it off, allow someone else to manufacture the same medicine, it is going to hurt R&D investments in the future, especially for these kind of diseases where it is difficult to anyway get investment. Now, there are 2 ways to look at this. One way is, yes, you buy that argument, obviously. The other way is the fact that no matter what happens in India, as long as there are patients in the United States and Europe who have that kind of disease that requires R&D and research, there's always going to be research and development flowing towards those diseases. That is, India is just not big enough a market right now, just in pure dollar terms, to shift R&D incentives for a lot of these multinational companies or even public funding that comes from the state, from tax revenues. So it may sound a bit cynical, that I'm saying that go ahead and break the patent is really not going to affect R&D to that extent because these guys are anyway going to develop drugs for those kind of diseases. But it's important to remember that patent policy has always been a component, of trade policy and industrial policy. There are a lot of people I know, like speaking in the pharma industry, a lot of people get sentimental about patents. That is, how can you take away something that we have, spent so much money developing? But even in the West, there are instances where, in the early part of the 20th century, the United Kingdom, which was a world power at that point, didn't recognize certain types of patents in the chemical industry because they thought that the Germans were getting a competitive advantage. In the 19th century, Charles Dickens went around the United States crying about the fact that the United States at that point didn't recognize foreign copyrights. So countries have always been very realistic about how they formulate their IP policies. If it's not benefiting your citizens, you can tinker around with it a little bit. Now, in today's age, it's become a lot more difficult to do so because of the World Trade Agreement. Because at some point, the United States laid down the law for India and said that if you want to export your textiles, etc., to our markets, you need to recognize our intellectual property protection. But there's still some leeway over there. The third way to control drug prices is the drug price control orders. So these are orders that are issued by the government under the Essential Commodities Act. It's a 1955 law. And these drug price control orders have been issued since, I think the first one was issued in 1962. And they're different. Basically, the Essential Commodities Act lets the government do whatever they want to do. They can regulate any industry, fix any price, etc., etc. So they come out, they lay down a drug price control order which specifies the formula as per which the price of the drug is going to be fixed. And they first used to follow what was called a production-based formula, where a babu was going to sit and calculate how much it's going to cost to manufacture this drug, and they will fix the price at that, and which is a bad way to let the Indian government do anything. The other way, the more recent formula that they put down in 2013 is they basically calculate the market price of the best-selling formulations, and they cap it at that. Now, again, the problem with using DPCO as a policy lever for controlling drug prices is whether or not you have control over the companies in question. Now, if it's a foreign company selling the drug at a particular price, and the government is going to fix a random, an arbitrary price as, you're going to sell it only at this price to us, it's very likely that the company may just not, send their product to India anymore. For Indian companies, as Dr. Gupta had alluded to in his presentation, they too don't like drug price control orders very much. So the National Pharmaceutical Pricing Authority, which is the authority under the Ministry of Chemicals and Fertilizers, which determines the price of drugs, does not have the greatest reputation in terms of assuring the pharma industry with transparency and some amount of predictability in how they're going to be passing their orders. In fact, there is some anecdotal reports that pharma companies have exited areas where the NPPA has gotten too involved. So it's always a little bit dangerous to ask the government to get in and set prices, especially if they are not doing the task very transparently. A fourth way to try and reduce drug prices, and this is something that happens on a daily basis even in India, is bulk procurement schemes. Right? So a lot of state governments set up a single medical services corporation. Tamil Nadu pioneered the model. And basically when you buy anything in bulk, the per unit cost reduces across the board. So if you have one medical services corporation buying drugs for the entire state public healthcare system, the savings can be enormous because you're eliminating the retail margins, which in India can be very high. So there's a reason that when you go to the big pharmacy chains, you get discounts of up to 40% at times, because there's also a lot of cartelization in the retail sector in India. So, and even the central government does this for its Jan Aushadhi stores that the central government has been opening. They do bulk procurement through a particular entity that they have set up. So in the private sector too, Tata Memorial has launched a program last year specifically for bulk procurement of cancer drugs. Because a lot of cancer drugs, as you know, are very expensive. And they've reported some phenomenal cost savings. And I think it's working on a pilot basis. They're going to ramp it up. So of all the solutions out there, bulk procurement may be something that may work, although I'm not sure of the economics of how this will be for rare disease drugs, given that the number of patients is always going to be very small. But if there are proper registries set up and there is enough data, there's enough predictability, the government is ready to front the money that's required to the manufacturer. For example, simple things like giving an advance payment to the manufacturer can help save, a few percentage points on the drug price. So these are more complicated mechanisms, but they can work, and crucial, one of the most necessary ingredients for these programs to work is having the information ready. So like patient registries, etc., definitely need to be ramped up in India so that the information is in place, and only then can the government negotiate under a bulk procurement program to try and bring down prices. The last point is, obviously, this was raised by the earlier speakers also, which is like better public investment and funding for research in India. Now, you can have the most wonderful minds in the country, a lot of them are here in this room today, but none of that is going to be of any help unless the government really steps up funding. And I don't see government radically stepping up funding anytime soon, but at least the existing money that is being deployed for research needs to be used far more efficiently. I mean, the amount of money that, as an outsider, I see being wasted in scientific establishments in this country is just mind-boggling. At one point, CSIR went on a crazy patenting spree. They were filing patents left, right, and center. And I suspect that they were spending far more money on filing and securing those patents than they were earning in royalties from those particular patents. So there are countless stories like this. I mean, during COVID, there was this drug that was released by the Ministry of Ayush called Ayush 64. This drug had, in its earlier avatar in the 80s, was released as an anti-malarial drug. Research showed that it was not working. It failed. The governments were still procuring it. And now during COVID, this drug made a comeback. And when I think AIIMS Jaipur or someone ran a pilot study and said that, this is not working, the Ministry of Ayush sent out a very nastily worded press release, putting them down. Now, so there are ways to try and streamline how, public money is spent. Like, I'm not talking about typical babudam, where they say that anything, unless it's applied research, don't spend on it, or they're looking at research as a return on investment. There are just ways to put in place mechanisms to ensure that the existing funds that are deployed for R&D are just used more transparently, regardless of success or failure of the ultimate research. And last but not the least, there needs to be a streamlined policy on the IP in publicly funded research, right? There are going to be useful inventions coming out of public labs. Right now, we have a very disjointed system across the country where each institute has its own IP policy. This is unlike in the US, where the Bayh-Dole Act lays down certain minimum criteria for all public funded research, including a safety clause for march-in rights. That is, at some point, say if there's a pandemic, the government has the right to march in and seize control of a particular patent and license it to other people. All these are considerations that we need to start thinking about right now to truly get the best that we can out of publicly funded research. Thank you. I'm 4 minutes over time. Sorry. Honestly, I have no idea. That's a good question. But this is also an area perhaps that needs more research on how exactly insurance companies in India are responding to the challenges of these particular drugs. Because at the end of the day, the insurance companies are the ones that have the most amount of money. And perhaps, like insurance law could be one of the policy levers that we use to address this issue, where we leverage. In fact, the problem is there's very little research into insurance policies. For example, even say pre-existing diseases, which a lot of these. Yeah. So actually, one of Shilpi's colleagues at Jindal is doing research on this because the Thakur Family Foundation had given a grant on pre-existing conditions in insurance policies and how India is looking at it. So, yes. Well, at one point that was the Government of India's official policy when they withdrew the first rare disease drug policy, where they put aside 100 crores, they withdrew it, and then they came out with some other policy announcements saying that you will basically help you raise money through philanthropy. But yes, philanthropy always will play a crucial role, especially with these crowdsourcing efforts that are there. The problem is these crowdsourcing efforts need to be regulated a lot better, because there is a lot of talk that some of these crowdsourcing efforts are basically fraudulent. So a little bit more transparency and streamlining may help in ensuring that philanthropy works more efficiently in India. Yeah, but I mean, so like in countries like the US, right? I mean, Obamacare, the entire thing was, let's get rid of this pre-existing disease clause in insurance policies and, compensate it through some other mechanisms, wherein basically everyone has to, there's a mandate now that everybody has to buy insurance if they can afford it, something on those lines. Yeah, there are other programs, but anyway, let's not get into that. But yeah, looking at insurance policy as a lead. I'm done. Thank you.
Okay. Yeah.
I mean, that anyway happens. People come here for cheaper drugs, they buy drugs in bulk quantities and go back. It's okay. It's not such a big drain on the, on the country. So.
Okay, Prashant, thanks very much for a wonderful, very important area. Now we have come, after this excellent discussions and lectures that we heard, the final part of today's function. I would like to invite Rakesh, Sudha, Gupta, Prashant. Okay.
Come. Somebody take a picture, please.
Okay, this is better.
Mr. Ramsagar, please come. I will also come. We have one more wrapped up. We have somebody. Professor Mahadevan, come. Open up one. And somebody take a picture, please.
Yeah. Yeah. So couple of more minutes to go. Yeah. Thank you, Chair, and ladies and gentlemen. I feel very proud that today, being National Science Day, what a befitting occasion this has been to mark the celebration of National Science Day. So in that context, I would like to thank Professor Alok Bhattacharya, the guest editor of the special issue, and Professor Sudha and Dr. Rakesh Mishra for the great effort in bringing out this special issue. We can hand over the Heritage Book of the Academy, Memoir of Sir Jayaraman to all of them. This was published in 1988, and the Academy got the copyright and republished with some new additional chapters. Also would like to thank Professor Y.K. Gupta for the very insightful keynote address. Thank you so much for that. We express our deep sense of gratitude to, again, Dr. Mishra, who moderated the panel discussion, and all the panelists, Professor Gayatri Sabharwal, Shri Madan Gopal, Professor Sudha, and Dr. Raghu for being part of this panel discussion. Our deep sense of gratitude also to Shri Prashant Reddy for that wonderful talk, which is very difficult. On behalf of all of us here, we extend our gratitude to Professor Rene Borges, one of the secretaries of the Academy and the chief editor of Journal of Biosciences, for leading the today's proceedings. Our sincere thanks to Professor Ramsagar, our own editor of publications, and all of those who joined us online for this event. On behalf of the editorial board, we thank our editorial colleagues, Srimati Sushila Rajagopal and Ms. Vinuta Sunil, and of course, Madam Srimati, for their support. So with that note, we would like to see all of you on a similar occasion. Thank you so much.
Make sure that everyone who's